Hi Algebra 2, welcome to the last video, video 3 of chapter 10a. So this is where we are looking at using combinations to count events where order is unimportant. So before we were talking about permutations, and that's when order is important, but here it is not. So we do have a definition here, a selection of R objects from a group of n where order is not important. We also have like our formula here, but how we notate is NCR, so that's our group and objects. Just like before, except instead of a P, it's a C. So in the calculator, it's the same steps. We click math, just like we did before. Then we go over to the probability, and then it's the third one down, NCR, right there. Okay. So part of this is understanding and trying to figure out, well, when do you use which one? I mean, so if you're like, well, I don't know when to use which one, well, that's kind of part of what we're looking at is how do you figure that out? So let's look at this example here for books. So it says you are picking 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7 book groups are possible? So the number of ways to choose 7 books from 32 is. So let's think about, well, what is our N and what is our R? So how many groups do we have? Well, we have 32 books, and we're trying to choose 7 of them. So we've got 32, choose 7. In my calculator. And that is 3,365,856. 365, sorry. And 856. Okay, so this next one says Miss Pernick has 14 lunch boxes, different lunch boxes to bring her lunch to school. During a normal week, she uses 5 lunch boxes, one for each day. On Friday night, she washes them all. How many different combinations of lunch boxes could Miss Pernick be washing on any given Friday night? So think about this too, like the order doesn't matter. We're not picking somebody for first, second, or third place, or anything like that, like awards, whatever. So thinking about our groups and how many we're choosing, we've got 14 of them, and we could be choosing 5. So 14, choose 5. And that would be 2002. Okay, and then last one on this page, Mr. Anderson is going to pick 5 people from a class of 32 to travel with him to a museum of mathematical history. How many different combinations of students could he take with him? So there's 32 students, and he's going to choose 5. So 32, choose 5. Order does not matter. So there would be 201,376. Okay. All right, next page. So and or. So there are words that we need to look out for when we're solving problems, especially in these word problems, so you kind of know what to do. So if you see the word and, that means we're going to be using multiplication. And if you see the word or, you have to think about addition. So for example, Mrs. Tam is on vacation and needs to pick pants, a shirt, and shoes to wear from her luggage. She packed 3 pairs of pants, 7 different shirts, and 2 different pairs of shoes. How many outfits can she make? So she's got 3 pairs of pants, and so multiplication, 7 shirts, and 2 different pairs of shoes. So multiplication for and we 3 times 7 times 2 would be 42 outfits. Okay, so now when to use addition. So Mr. Jacobs wants to pick 2 students. Okay, so he wants 2 students from a single class to give a star student button to. He has 14 students in his 4th hour and 32 students in his 6th hour. Okay, so 14 in his 4th hour and 32 in his 6th hour. How many different combinations of students could Mr. Jacob give the buttons to? And remember, he wants to pick 2 students, but they have to be in a single class. So he could only pick 2 students from his 4th hour. So he could pick 2 from his 4th hour or from his 6th hour. So let's think about 4th hour for a second. We have 14 students total, and he could choose 2. Or he has 32 students total, and he could choose 2. So then that's when you would use your calculator. So 14, choose 2 would be 91. And 32 students choosing 2 would be 496. And if you add those together, you get 587. Okay. So let's look at this next one here, deciding to multiply or add the combinations. So a local movie rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. So really quick, let's think about how many movies we have total. So 12 plus 8 plus 7 plus 5 plus 9. So our total movies would be 41. Okay, so now let's read part A. You want exactly 2 comedies and 3 family movies. How many different combinations can you rent? So you want 2 comedies and 3 family. So let's think about how many comedies there are. So there's 12 comedies, and you want to choose 2 of them. And notice here, and so we would multiply 3 family movies. So it looks like there are 9 family movies, and we want 3 of them. So I'm going to write 9, choose 3. And then that's something we'd have to type in our calculator. So let's figure out what 12 choose 2 is. And 9 choose 3. So we've got 66 times 84, which means we would have 5,544 combinations. Okay, so now you can afford at most 2 movies. How many movie combinations can you rent? So let's think about that language though, the at most 2. So that means we could rent 2 movies, or we could rent 1 movie, or we could rent 0 movies. So it didn't ask us like what type of movie or whatever. But we've got 41 movies total, and we could choose 2 of them. Or we have 41 movies, and we could choose 1. Or, which would be addition, we have 41 movies, and we could choose none. Okay, so figuring out what all of that is in our calculator, well, 41 choosing 2, 41 choosing 1, and 41 choosing 0. So that would be 820 plus 41 plus 1, which gives us 862. Sorry. Okay, so now let's look at the next page. We're almost done here, you guys. So you stop at Subway for $6 footlong for the second time. There are 5 types of bread, 7 types of meat, 14 veggies, 6 sauces, 7 soda options, and 9 types of chips. How many different types of sandwich, chip, and drinks could be made if this time you get to select 1 bread, 2 meats, 5 veggies, 2 sauces, 1 soda, and 1 chip? So I wrote them out here for us because remember, this is also an and problem because we're selecting 1 bread and meat and veggies and sauce and soda and chip. Like this isn't an or. You don't get bread or meat, right? It's both of them. So it says we have 5 types of bread and we're choosing 1. Then we had 7 types of meat and we're choosing 2. And we have 14 types of veggies and we're choosing 5 of them. Then we had 6 types of sauces and we're choosing 2. We had 7 types of sodas and we're choosing 1. And 9 types of chips and we're choosing 1. So in your calculator, and I'm not going to take the time to do this, but in your calculator, you would find that that is 5 times 21 times 2002 times 15 times 7 and times 9. So you'd have to figure out each of those individually, and that would give you 198,648,450 ways. And you can go ahead and stop the video and just try that out on your own just to make sure you'd be able to get it. All right, let's look at cards. I'm not going to do 11 and 12 here. I just want to take a little look at cards because we see those a lot in probability. So this says find the number of possible 5 card hands that contain the cards specified. The cards are taken from a standard 52 deck. So if you haven't ever played cards, well, now would be a great time actually with all of us being at home. But things to think about. So here we have a standard 52 deck. We have our spades right here. So these are our spades. We have our hearts. We have our diamonds and our clubs. And there are the black spades. Then we have the red hearts, the red diamonds, and then the black clubs. So you want to make sure you notice the colors here. And then notice that there's 13 in each group. So we have 13 of these. Okay, so now this problem here says, well, what's the probability of us choosing 5 red cards? All right, so let's think about, well, how many red cards are there? So we've got 13 red cards here and 13 here. So that means we have 26 red cards total. And we're wondering about choosing, we need 5 of them. All right, okay, so that would be 26, choose 5. And in our calculators, that is 65,780. Okay, and then let's look at 10. So 4 spades and 1 card that is not a spade. Okay, so notice here we have that and language. So the chances of us choosing 4 spades, well, how many spades are there? So if you look, we've got 13 spades, choosing 4. And would be multiplication, 1 card that is not a spade. Okay, well, how many cards are not a spade, right? So 13 of them are a spade. So there's 52 cards total minus 13. So that means 39 of our cards are not a spade. Okay, and in our calculator, if you guys go ahead and try that out, you should get 27,885. Okay, we've got 2 more, you guys. Stick with me. I know this video is a little bit longer, but at least I didn't have to separate it into 2. All right, so let's practice with at least and at most problems. So your YouTube playlist has 5 videos. You want to watch at least 2 of the videos, okay, during your math class. How many different combinations of videos can you watch? So what you have to do when you think of the at least, at most. So at least. That means you could watch 2 of your videos, or you could watch 3 of your videos, or you could watch 4 of your videos, or you could watch 5 of them. So you have 5 videos and you could choose to watch 2, or you have 5 videos and you could choose to watch 3, or 5 videos and choose to watch 4, or 5 videos and you watch all 5. So you would have to type that in your calculator. Just a quick reminder on how to do that. I would do 5, math, go over to probability, the third one down, choose 2. So that gives me 10. Okay. And then 5, probability, choose 3, also gives me 10. And then here this would be 5, and then that would be 1. So total would be 26. All right. And last one, the PC girls basketball team plays 26 games during the regular season. You want to attend at least 23 of them. How many different combinations of games can you attend? Okay, so let's think about at least 23. Okay, so that means you could go to 23 games, or you could go to 24 games, or 25, or you could go to all 26 games. Super fans, okay? So there's 26 games, and you could choose 23 of them, or 26 games choosing 24 of them, or 26 choosing 25, or 26 choosing 26. So when you type those in your calculator, you get 2,600 plus 325 plus 26 plus 1. So your answer, when you add those together, would be 2,952 ways. Okay, so I'm going to stop here. Just a little note that I wrote, make sure you practice, okay? These problems can be tricky and they change up. Like they're not always going to be the exact same story or whatever, right? They're similar, but they're going to be different. So make sure that you do the homework for sure. But also there's extra practice folders and review materials. The extra practice is your pink sheet like we normally do in class. So I added that as well as the answer key. So give those a try. Practice, and let me know if you have questions. Thanks.